Welcome to Oracle ADF TV. My name is Frank Imphius and I'm from the Oracle JDeveloper and ADF Product Management team. In this recording we talk about the performance options or the performance optimization options that we provide with Oracle ADF Business Components. However, before going to the subject, let me just go back to the previous recording where I talk about general expectations you can have and common sense and assumptions that you should do about tuning applications. And the two things I said there is that you shouldn't just make up performance goals. Instead, you should clearly define performance goals for each of the tasks and probably for each of the pages that you have. Be very realistic based on the data that you query, the amount of data you query and the amount of data that you show. Now, once you have a very realistic expectation based on the importance and the data on a specific page or a task, you can then start measuring performance and see if there is a difference between what your expectation is and what reality shows. I also talked about the importance of realistic measuring and realistic payloads, and I also said that probably the framework does it right to some degree. So that is that we have a long history with Oracle ADF Business Components with internal and external customers, so that the framework itself is kind of optimized for good performance. Still, there are some settings that you can do based on the use case you have, and that's what we're covering in here. The first talk about is ADF Business Components shared application modules. Don't know if you work with that feature. Well, if you have a lot of boilerplate data to show, it's like lookup or list of values, then typically if this is all the same data, you would use a shared application module and not query the data with the individual per instance application modules, because you will reduce the number of database fetches using shared data application modules big times and thus increase the performance. However, what you need to be aware of is that application modules that are shared, they are not transactional. That means you cannot use them to delete or update data, and they shouldn't be filtered because the filtering of the data will apply to all of the instances that run for the specific application. So you want to read up about shared application module because that definitely is a performance improvement. Another topic to talk about is the locking behavior in ADF Business Components. In 11G Release 1 and previous releases, the performance was such that we set the locking behavior to pessimistic as it was optimized for desktop use. Now with the web, the optimized locking is of a better performance because it excludes users from locking out other users from a specific row in the database, and that will then lead to unnecessary rollback behavior which you don't want. So make sure that you change all of your settings to optimistic and not the pessimistic we had in the past. Well, for new releases, if you started your application development with JDeveloper 11G Release 2 or 12C, you're fine because we changed the default behavior for that. So it's all now optimistic. When you work with optimistic behavior, or in general if you build web applications, be aware that the web is stateless. So we make to appear it's stateful with ADF Business Components. In fact, it's stateless. That means that your database connection that you have might not be the same database connection you get when a request returns, and for that reason you cannot rely on the existence of any global variable state in the database or PL/SQL state. So you always have to rerun this. So if you have code that relies on variable values being available, make sure that you inspect these packages and make sure first of all you correct them so they behave properly, and second that they're not doing any kind of expensive operations, because that would mean they're now doing it every request instead of just once as you might have added during the desktop times. So use Oracle SQL, that's another recommendation. So if you know that you work against the Oracle database, use Oracle SQL types because these are optimized for better performance. If however you have to work with a variety of databases, if your application has to work with IBM, with Oracle and maybe with SQL Server, then you have to use SQL 92 as the data type that is retrieved. On the ADF Business Components level, if you go to the Tools, Preference options in JDeveloper and then go to ADF Business Components, there's an option that allows you to set the ADF Business Components objects to a deferred loading. Now deferred loading means that those objects are instantiated and queried first when they are used and not just when the application module starts. So it's a new default for 12C. if you're on an older release, you want to at least try this. You want to set the view object load behavior, for instance, to deferred loading, or just go to the application module settling and see what that brings. If it doesn't bring anything, then you can just switch it back. But the new default is that we set this to deferred so that the application objects are not created upfront, but just on a per needed basis. Application module pooling, and I just said that the web is stateless, so we make it appear stateful. The way that we do that is that we put a little token that we send with each request, which is an ADF Business Component specific token, and this token, or cookie if you want to call it, actually identifies a specific request. Now, in an idle world, every application module that is instantiated by a specific request will also handle the second request of the same user, so that the state for this application module can be kept on the server. No requerying has to happen, so everything will be just as it was when the user issued the first request. Now, in reality, the web doesn't work like that. However, ADF Business Components does, and for this we have a mechanism that is called application module pooling. And the application module pooling will make sure that instances of an application module can be configured in the way that they are pre-started, in the way that they are maintained and kept, and in the way that they're kind of put back to kind of retirement, or just put back to wait for the next request to come in. So you can imagine that if a request comes in and then comes back in time, that it's possible for the system to give it back the same object, the same instance of the object, in which case all the data that previously were queried are still there. Now, for this application module pooling instance, you want to make sure that you read about what it does. You want to go to the Fusion middleware documentation, to the Fusion developer guide, and there we explain everything that has to do with application module pooling. So you want to not necessarily stop the video here, but after that you should just look it up and read on the matter, because there's a lot to say and a lot of configuration settings that you want to try out for your application and performance optimization. Now, for application module pooling, there must be something that makes this work, because you can imagine that if you have a pool of application modules that would be good for 10 users and eventually there are 12 users on the system, something must happen between the requests. Now, what happens between the request is passivation and activations. So what ADF Business Components is really good at is to recognize if it has enough application modules in the pool, and if not, and if there is a request coming for which there is no application module, it will look in the pool to see if you can hand over an idle module. What it would do before is it would take the module and it would then passivate its state, which means that it will just save the custom hash map. So for custom data, it will save transient attributes, it will save query state, query pointers, and so on. That will be serialized into an XML document, and the XML document then would be loaded into the database. Now, doing this allows us later on to activate the change. So if the original user of this application module comes back, we activate the change in that we pull the XML document from the database and then initialize the application module that we want to give to that user based on the previous settings. So that could result into queries being requeried to the database, but at least it will give back the exact state to the requesting user, which then for the user makes ADF Business Components or the ADF application appear as stateful, which is a huge benefit. Now, from a performance perspective, we say, yes, use application module pooling and passivation, so don't disable it. We only say, well, disable it maybe for testing purposes, but not for production. During production, you want to keep application module pooling, but then you want to make sure that you more or less avoid passivation. Now, why do you want to avoid passivation? Because of the cost of it. Yeah, passivation is good, but you want to avoid it for as good as you can. Yeah, so you don't want to go over your memory that you have available, but within the range of your memory, you want to avoid passivation and activation. So first of all, what you want to do is you want to set the init pool size for application modules to the reasonable peak level of your application. Yeah, so this means that when your application starts, all of the application module instances will be created, which means that after 1 or 2 warm-up calls that users will have, all of the other requests will be quite performant and fast. Then you want to set the max available size for the pools to your peak level. So you want to make sure that the average peak level is covered by individual application module sessions or instances. Again, of course, this depends on the memory that you have on the machine. So if you expect 50 users to be handled, but your memory doesn't allow to handle more than 30 application modules being in memory, then you will have to buy into using passivation activation. And remember the triangle that I showed on the first presentation, you're basically shifting a memory requirement to CPU, because activation passivation will go for the cost of CPU but would avoid memory in that it wouldn't launch additional application modules. However, if you can, and your user population is say 50, make sure that you can have 50 application modules waiting, hanging around for the users, because this way is the best guarantee that every user will get the instance back that the previous request was using. The next step to configure then would be the recycle threshold. Now the recycle threshold should be set to max available size. And the reason here is that the recycle threshold is that if you start with say 50 application modules, and then after a time where the application modules are just waiting for users to come in, the recycle threshold will just bring them down. So if you set recycle threshold to 30, it would just bring down the available application module size to 30. Now that could lead to passivation activation, but it could also lead that an initial request then from a user will have to restart another application module instance. The maximum active or inactive age, that should be bumped up. So the application module shouldn't be closed only because it was waiting 5 minutes or 10 minutes without any interaction with the user. That's something that you want to balance a bit, so you don't want to set it to 3 hours, but actually realistically for your application. And then the time to live, set it to -1, which means that application modules are never dismissed only because they were used 10 or 13 times or 30 times or 50 times. Just it will stick around until it's kind of closed for some other reasons. So this is the best recommendation we can give, and as you see on the slide, it can boost up your response time to 30%. And the reason here is that you avoid all of the passivation activation to happen, and that is good for the performance. What about database connections? Well, database connections, you can assume that there is an application module which is a root application module, and that will require a database connection. Now this database connection, if it's a JDBC connection, is something that needs to be established, started, and then it will be handled in the database pooling of ADF Business Components. Now our recommendation here is that you don't use JDBC URL, but that you use JDBC data sources that you can manage on the WebLogic server side using Enterprise Manager or the WebLogic Server console. So you want to externalize the database connection pooling and the configuration of it from ADF Business Components, so that you have the ADF Business Components independent of all of these database configuration settings. Still, the root application module will take one connection, but once it's done with it, it will just hand it back and it will become available on the WebLogic Server database connection pooling. So that probably wouldn't be any kind of downtime or disadvantage you get out of this. More likely you will get advantages of using database JDBC connection on the WebLogic server side than using JDBC URL, which was the default that we did in 10.1.3 and in 11G release 1. Now that again has been changed in 11G release 2, and in 12C you will have JDBC data sources instead of JDBC URL by default. However, for existing applications, you're going to change that because that is the recommended way. And then there's a lot of intelligence that we put on the task flow levels, that we kind of automatically turn root IAMs into child IAMs. And Chris Muir, for this ADF TV recordings, did a session just on this pooling topic. You want to go back and watch that video just to learn about what internally the framework is doing to your favor. So for sizing, well, I mentioned that you want to avoid passivation and activation. So for that reason, you may want to make sure that you always have enough application modules as peak level is what you expect. However, if you don't have this memory, then you can assume that an application module can handle, including passivation activation, up to 10 to 15 users. So that means if you're expecting 50 users, you can divide it by 10, so you know how many live application modules you would need as an instance. However, always recommended is to look for more memory and have more application modules in the pool than you really need, because this way performance can be increased. So next topic is to talk about view objects. So there's not much to say about application modules. You find more in the Fusion Developer Guide. However, for view objects, now this is the mother of all queries, and typically where we go and see things going wrong is with queries. First of all, you should try to define SQL queries in a view object for as much as you can declaratively. Just use the declarative options, because this way we can make sure that the design time provides the optimized SQL query for the database that also allows you to set indexes and optimizer hints so that the performance for the query is optimal. Now, if you have to put in manual query, maybe you have a union or whatever statement that you cannot build declaratively, then make sure that you index the tables properly and that you can make use of indexes. If, for instance, the whole goal is to query two data tables in your query, in your custom query, you should consider using two entities and just having a view object based on the two entities, and then again the framework will do the trick and create a better performant SQL query for you. So when you build view objects, and if you build view objects just for read-only access, then make sure that they are based on entities. And the reason here is that an entity object represents a row in the database table. Now, once queried, we put it into an entity cache, and this entity cache is available also for read-only queries. If the view object is read-only, for as long as you base it on the entity, it will participate in the following from data being queried into the cache. In the past, and I'm talking about the long past, so before 10.1.3 probably, our recommendation was not to have read-only view object based on entity cache. Now the framework optimized, and for that reason you can optimize your application and use entities for read-only queries as well. So let the framework really optimize your query performance. And don't be afraid to have multiple instances of a view object. For those a bit more experienced with ADF Business Components, you know that you can create the view object definition, and then for the view object definition you use view object instances in your data model. So in the application module, data model, you see instances of the view object which you can then filter, for instance with view criteria individually. Now don't be afraid to use multiple instances, because that's not really eating any bread and butter. You want to make sure that the view object by itself is more treated as a blueprint, because if you duplicate the view object definition itself, then that is like drawing a new blueprint for a house to build. So that's kind of an additional piece of metadata that would need to be loaded. So don't be afraid to use instances, because that is how ADF Business Components is designed on. So for view objects, well, I mentioned the framework probably does it right, but there are some areas where we know the framework doesn't do it right for all of the query requirements you have. And so there is a tuning dialog for view objects. Well, you find the same options also for view object instances. So if you go to the data model in ADF Business Components, select the view object instance, open the property inspector, you find the same set of configurations that you can do there, and we suggest that you do that. Well, there's a default setting for all view objects, and that's probably something that's going to change from release to release based on our experience with the overall performance of the framework. Now you see a list of properties on this screenshot here. You see that you can determine or specify the batch sizes. Now that is the number of records that with every fetch we get out of the database, and for each of these fetches, so if it's set to 1, we reserve memory or allocate memory in which we keep the row then for further processing. So the bigger that value is, the more data we fetch out of the database and the more we put into memory. However, for the efficiency, having a batch of 1 probably doesn't mean it's a good setting, because that means that in a fetch for 100 records we go to the database 100 times. So we want to have more batch fetching here. All of the settings that you see here are well documented in the Fusion Developer Guide. I will go over some of them in the following, but just take the time and read the documentation to get detailed information of all of the settings. So as said, the view object has quite some knobs to turn and change. Defaults probably do it right, but always look at your use case. Look at, are you requiring page ranging, or do you require scrollable data? For instance, that is two settings in the database ADF Business Components view object as well. So always make this based on your requirements. So primary, consider the batch size based on the use. If the view object just returns one record, maybe a view object that serves the profile data of an authenticated user, if that is just one, then you can go away with the batch size of 1. But however, if you populate a page and that has a table and the table shows 25 rows, you want to set the batch size higher, maybe 30 or something like that. The access mode will depend on the use case as well. I said page ranging or scrolling. Just read up on the two options and you identify the use cases and then map this to your use cases. So the fetch size basically decides the number of records that we read from your database, and that is what I said previously. The JDBC implementation is it that internally allocates memory and that matches the fetch size just to hold up the result set that you get, and then it will dismiss it and we'll just get the next set of data out of the database. Now the data is not lost even if the JDBC result set dismisses it, because it will end up in the ADF Business Components entity cache. So the data will be cached. However, if you fetch 100 or 1000 records out of the database, then the batch size will determine the number of fetches that are issued by the framework. And now you don't want to set it to 1000, you want to set it to a reasonable number. So typically the recommendation is to go for what you have in the page definition file. So in the iterator settings you have a page ranging setting, and that's typically set to 25. If that is the case, 25 plus 3 probably makes a good fetch size, so that when users scroll in a table or in a form, they have a reasonable performance coming out of the database queries. So for UI bound view objects, so if you have a user interface based on a specific iterator, make sure that the fetch size is less than 30. However, if you have different views pointing to the same iterator, so maybe you have a tree, you have a dashboard, you have a pie chart or whatever pointing to the same iterator, and or I should say the same view object through different iterators, of course, then look into the iterator maximum page ranging and use that maximum instead of the 25, which is the default and the average. Yeah, so always go with the maximum. But you will figure that out when you start working with that, that this can be an option to really tweak your application performance. So the maximum fetch size, now that's decide what is the maximum number of records that a view object can retrieve from the database. If developers don't pay attention, then the risk is that in fact users issue a query that queries for all of the data in the database. Now if you have 1 million records in the database and someone sends a wildcard query that queries for everything, you can imagine that that is an unnecessary query, and also the performance will just go down. So you can say, okay, no matter what the query condition is for my view object, I want this to have a limitation in the number of records it returns. Well, another use case for that is if you want to have kind of a ranking approach where you say, okay, always show the top 10 of a specific query. And with this case, you would just set the maximum fetch size to 10, and then you would just have an order by or a query, and it automatically will make sure that you see the top 10. If you have a query where you know that it's only one row that is returned, you could even set it to 1. Though that's a really rare use case. Typically go with some sort of top ranking or just reasonable maximum fetch size to avoid that users query all the data out of your database. So the range size decides the number of records read into the middle tier for a single record. So if you typically, and that is the recommendation I had before, if you have multiple UI components bound to the same iterator, then the range size actually of that component should be set to the maximum of it. So all of the bounded components will just have one maximum. So the one with the biggest requirements, typically a graph, will determine what you set as the range size for the fetching of the data that you do in just one fetch to the database. Again, if you want to query 100 records, the range is set to 10, and you go in chunks of 10 records. And you want to play with it. You don't want to overdo it, but you don't want to put this too small. So there are options to globally set the row limit for view objects in an application. So you can set the row fetch limit on the ADF config file, in the ADF config XML file. This is something we added in one of the more recent JDeveloper 11G Release 1 versions. It's also available in 11G Release 2 and in 12C, so you want to have a look at that file, and this could be set to prevent users from querying all data out of the database. You can also override the behavior. You can create a view object impl file, and in that view object impl file you can override the get row limit method, and then conditionally maybe tweak the maximum fetch size that is allowed by a view object. For tuning tricks, I also mentioned, make sure that you use the declarative option, make sure that you support table indexes, make sure that you support database optimization hints so that your application queries data as quickly as it can. Also be aware that if you put large custom select clauses in, that these typically have problems if you don't pay attention with the indexing. So make sure that you keep it smart and simple and have the framework doing it right for you. So view objects, view criteria, these are named where clauses that you can add, and you can either programmatically add this at runtime, or you can at design time already add a where clause to a view object instance, and we recommend doing this because that allows you to filter the data. And even if you don't want to have pre-filtered view objects, probably you will use the query component or the quick query component. Don't use the all queryable attributes view criteria, which is there by default, but create your own. And the reason here is that the all queryable attributes is something that you cannot control. However, if you build a view criteria that maybe even allow you to filter all of the attribute, it allows you to set attributes on that view criteria to required or selectively required. So that means that users cannot issue a blank query. So they always have to provide some sort of filter conditions, and that is of a much better performance than, again, having them query the whole database. Also make sure that you're aware that if you have any conditions that include contains or ends with operations, that this typically cannot be database indexed. So you want to make sure that you avoid these kind of operations for the sake of performance. Next topic is something that's kind of hidden from the eyes, but a very interesting topic to cover, and that is typical gotcha, which is having to do with the fold-in behavior in ADF Business Components. So what we see on this slide here is that there is an entity object which has an employee number, it has a first name, a last name, salary, and a commission. Now this information is now accessed from a view object, and this view object may not need all of the attributes, so it will just query for no first name and last name, which is fair enough because the query now goes to the database and just asks for these attributes, so the entity object is not completely filled with value and with data. And again, it's not a bad decision. Yeah. However, if then in the following the same is performing a validation, so you have an entity validation that requires the salary to be available, like you want to make sure that if the user is a manager, then for instance the salary should be above $5,000, euro, whatever. Yeah. So because the sales value or the salary value is not available now, what will happen is that the framework will get it for you. So the framework now will issue a query for all of the other attributes that it hasn't loaded yet. So that's a fold in. So it will make sure that the data that is missing doesn't produce an error, but instead will query it. Now, and this will be a sequential query. So it's not going in a batch as you could configure on the view object. Now this goes sequentially, and that really is what costs at least time and resources. It's not necessarily expensive what we're doing here, because what we perform is a key lookup. So we're not going by any kind of bad performing query here. However, we do this for every row. Now imagine you're going for hundreds or thousands of records, and for 100 and thousands of records you didn't query the salary attribute here, and then the cost would be that 1,000 times probably we fetch the database for the value. So what is the recommendation here? If you know that you have a dependency between attributes, make sure that the dependent attribute always is queried with the view object so that the data is basically coming in. So very important that you have this as an option. So next further best practice is always have primary keys. Another one, well, the primary keys I think is common sense, because we want to make sure that when you sort data, that this data actually always has a primary key associated when you have a cluster as well. There's no guarantee that the row ID is persistent in the sense that it's unique and the same. So you want to use primary data, because when we do lookups by key value, then a consistent primary key is of good use and good recommendation. Avoid list validators. Now this is something that not many customers know. You can provide validation on an entity object based on lists, like if user is in manager IDs, yeah, so that kind of a list validation. Now the problem with that is that we actually don't perform the list validation as a batch. We'll just go and populate it sequentially, one after the other. So that's quite expensive here. When you use set attribute calls, then make sure, same for get attribute calls, that you use the index of the column or just generate helper methods, which you can do if you create a view impl file. And then this view impl file will typically have methods like get emp name for getting the employee name, and internally we'll use the index value. So this is a much better performance than just passing in the name, the string name of it. You won't be probably able to measure that with your watch or something, but purely from knowing how the internal framework works, addressing a column or an attribute by its index is of better performance than using the string name of it. So this concludes this detour to ADF Business Components optimization and performance tuning. Again, make sure you go back to the slide that tells you where in our documentation we document all of the ADF Business Components property settings. Don't go overboard with it. Remember the slide I showed on the first session, that premature optimization could quickly end up in a mess, and that you spend a lot of time on areas where you cannot improve anything anymore. However, being aware that these options are available and how these work and what the pros and cons are definitely makes you a better programmer. There's a third recording on performance and tuning, which is just then covering task flows and the view side of ADF.